Hey everyone, this is Derek, and in this video we're going to look at graphs of exponential functions, and this is not going to be an exhaustive look in any way. This is just going to be a little introduction so that hopefully you kind of have a sense as to what an exponential is and what they look like. So here's a very kind of basic version of an exponential. I have one up here. Let me write it a little bit bigger. F of x equals a b to the x. So that's going to kind of be our basic form. This a is multiplying, so it's not being affected by the exponent. The b is the base. The a is going to kind of change where the y-intercept ends up. And then the x, this time we're plugging in for the exponent instead of normally, this is like squared and we're plugging in for the base. So here the base is going to be a value, a constant, and the exponent's what's changing. So for this one, I'll write it bigger in case people are watching on a phone. It's y equals 5 to the x. I'm going to make a simple t-table, and I'm going to make this one too big just to show you why. This is too big. And then the other thing I'm going to say is on this homework, you're not going to have to graph these yourself. You're just going to have to match graphs. So the object of this is really just to kind of get you familiar with the idea of an exponential so that we'll use them for other stuff. The idea of exponential growth makes sense because you have a picture in your head. So if I put in a -2, 5 to the -2, also a good chance to review negative exponents. That's 1 over 5 squared, and so that would be 1 over 25. If I put in -1, that would be 5 to the -1, so that's 1 over 5. Remember, anything to the 0, 5 to the 0 is 1. 5 to the 1 would be 5, and then 5 squared would be 25. So if you look at my little graph here, the difference between 1/25, which would be like right up against the axis, and 1/5 is almost negligible. I mean, you can't draw it accurately on a graph this small. So that's what I was saying. Any points past here at -3, it's 1 over 125, so that's like right up on it. So you can't really draw it. So that's why really anything down there is sort of silly to graph. 0, 1, that one's cool. When x is 1, y is 5, that's cool. And that right there is what I'm trying to get you to see, is it starts off with this piece that kind of tails in towards the axis, which is usually not the piece, at least in this class, that we're interested in. But what it does is it grows, and the next point would have been when x is 2, I'd be way up here at 25. So it's not linear. That's what I want you to see. It's not like it goes over 1, up 2, over 1, up 2. This went over 1, up 4, and then from there it's about to go over 1, up 20. So the rate of change is changing, and they grow very, very quickly. So that's what an exponential looks like. These next couple are just to kind of show you different things they can do, and I need to show you E in case you haven't met E from a previous class. So for this one, this is y equals 5 to the -x, xy. So again, if I just plug in these values to actually do something interesting, when I put a -1 in there, it's going to act like a 1, right? Because it's negative and -1, so that's 5 to the 1, so that'd be 5. 5 to the 0 is still 1. 5, now when I put in a 1, it acts like a -1, and I get the 5th. So I'm going to get the same graph, it's just now, it's like it's been swung, like this was a hinge, and then pivoted around the axis. So it's been what's called reflected about the y-axis. And so that one would look like that. So it is possible, while these things, this is kind of your basic one, you can flip them around this way, this way, this way, so they can reorientate, but there's two orientations. The other one that you're going to run into is this y equals e to the x. E is approximately 2.718, and then that number goes on forever, like pi does, 3.14, and then that just keeps going. E is another irrational number. It ends up being the base of our natural log here in the next section. So we're going to see a graph of it, and here it just seems like, why would we possibly want to graph that? But it ends up being a super useful function, and especially next quarter in calc, this is like the easiest thing to work with ever. So let me do a quick little graph on it. So x, y again, -1, 0, 1. And you should have a button on your calculator that will look like ln. The second function of that button should be an e to the x. So that's what I'm using, is the second function of that button. That's the other thing I want to show you in this. So if you go e to the -1, I think it comes out 0.36 something something, and I think I have it as about 0.4 in the notes. Anything to the 0 again is 1, except for 0. And then e to the 1 is this 2.7 number, approximately. And so we're going to get basically the same shape graph. It's going to trail into the axis. They're all going to be this shape. It's just how fast they grow versus not. The bigger the base, the faster they grow. And then this last one down here, it just has this coefficient out front. So what's happening is, like, if I think of y equals 2 to the x, xy, negative 0, 1, 1, to the negative, that'd be 1/2. And then anything to the 0 is 1, and then 2 to the 1 would be 2, versus y equals 3, and then 2 to the x for the same values. It's the exact same graph, it's just everything's getting multiplied by 3. So this is now 3/2. This is now times 3, so 3 times 2 is 6. So it's just tripling all the outputs. So what would have been kind of a shorter graph like this, and then go through 4, now it's tripling those, and so I'll be -1 and 3/2, 3 and 1, and oops, 6 is up there. I missed that one, but hopefully you know what I meant. So it's kind of stretching it out along the y-axis.